Hi guys, Dr. B here. This is AP Chemistry topic 6.1, endothermic and exothermic processes. The objective for this topic is to be able to explain the relationship between experimental observations and energy changes associated with a chemical or physical transformation. So we're going to be looking at temperature changes, energy changes, so types of reactions, specifically exothermic or endothermic. So we're going to look at those as well. So 6.3, 6.1, there's a lot on the slide, so you have to pay attention. So many reactions and changes involve either the absorption or release of energy in the form of heat. That can either be exothermic or endothermic. So endothermic means that heat is absorbed. And if it's exothermic, that means heat is released. But where is it releasing or absorbing? I'm sorry. That's the part. That's the main crux of this particular lecture. So the system is what you are studying. So it can either be beaker, salt, water, a thermometer, or it could just be the salt that is doing the dissolving. Your surroundings are everything else. So maybe the air, it can be the beaker, it can be the water. It just depends on what is the focus of your reaction. And the universe is the system and surroundings together. So it sounds kind of like physics a little bit, but just remember system, surroundings, and universe. So when I talk about the system and surroundings, you have to remember, you have to be able to recognize based on the question, what is what? Okay, what you're studying is a system, everything else is just the surroundings. It is important to always define the system and surroundings. Heat or work is always transferred between the system and the surroundings. Therefore, the energy of the system equals the opposite in the net of the energy of the surroundings. So that means that the energy of the system versus energy of the surroundings, it is going to be some kind of terminology. It's going to be equal in magnitude, but opposite in sign. That's terms you should be able to, you need to be kind of putting in your head right now. So the quantity or amount of heat Q, I didn't mean to do that. So the quantity or amount of heat of Q is the amount of thermal energy transferred from something that is hotter to colder. So it's always going from hot to cold. If the thermal energy is transferred from the system to the surroundings, the heat will be negative. There's a lot of colors here, but I wanted to stand out. The thermal energy is transferred from the surroundings to the system, the heat is positive. And it'll always be equal in magnitude but opposite in sign. That's the part that I was kind of referring to. Work is the energy needed to move something against a force. So we're going to look at expanding gases on a piston. So chemical work is often thought of as work, which is negative P times delta V. So pressure times change in volume. If the system is pushing on the surroundings and expanding a piston, the work is considered negative. If the surroundings is pushing on the system and it's compressing the piston, work is positive. So a lot of like signs of positive and negative here, so you need to kind of get those things straight. Endothermic processes, just a refresher, heat is absorbed from the system. Enthalpy, delta H, is positive. The products are higher in energy than the reactants because energy needs to be absorbed to go to a higher position. Some phase changes, melting, boiling, vaporization, sublimation, changes that are involving breaking, separating. Your heating curve, your heating phase diagram, all that type of stuff. So notice it's going up in temperature. As you're going up, you've seen this before in regular and honors chemistry. Heating ice, and then you reach, so it's still solid, but it's heating, but then it gets to B to C, in that line, that's already melting phase. Then go up heating the liquid water that's still liquid, and then you go to vaporizing water, so vaporization, and then heating a system, heating steam, I'm sorry, I misread that. That's when it's a gas. So just to be thorough. There, you need that, here, 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 here. So basically everything in there. All right, cool. Exothermic processes is heat is released from the system to the surroundings. Enthalpy is negative, delta H is negative. Products are lower in energy than the reactants, so freezing, condensation. Essentially, you're combining stuff, cooling curve. Same, it's the opposite of the heating curve, but it's in the opposite direction, essentially. Instant coffee. Ooh. I can hear a siren. Instant coffee is made through a process called freeze drying. So this is what freeze drying is. I'm sorry. Okay, so you cool something down until it becomes a solid. So you make coffee the traditional way. Okay, let's go. And then it becomes a solid. Finally, the pressure is decreased and the ice coffee, or the ice, will change to gas, leaving behind freeze-dried coffee granules. Identify the two phase changes that take place and classify them as endothermic or exothermic. So try to avoid writing exo and endo, write out the word. So the first one they talk about is freezing. Freezing is liquid to solid. So for it to go from a liquid to a solid, so remember, liquid has more energy compared to a solid. So this is going to be exothermic because the energy is released. The next one is going to be, I want to do that. The next one will be sublimation because it's going from solid to a gas by changing the pressure. Solid to gas. So it's going from compact, not as much energy, to gas, more energy. That means it has to absorb energy for this to happen. So this is an endothermic reaction. A solution of ammonium nitrate was created by dissolving 5.02 grams of ammonium nitrate in 100 mLs of water at 22.3 degrees Celsius. After forming the solution, the temperature was 17.3 degrees Celsius. Did heat enter or leave the system? What is the sign for Q? Was the dissolution process endothermic or exothermic? So the first thing you need to be able to do is, so here's some notes for this, is be able to define the system and your surroundings. And this will equal my universe. Well, for this, I guess. This is not my universe, but whatever. Fine. All right, so you're forming a solution. You dissolved 5.02 grams of ammonium nitrate and you put it into the water. So did heat enter or leave the system? So define the system as the solid. Surroundings is the water, beaker, air, etc. We notice that after making the solution, the temperature drops from 22.3 degrees Celsius to 17.3 degrees Celsius. So what you're not taking the temperature of the solid, you're taking the temperature of the surroundings. So that means that if the temperature drops, the temperature of the solution goes from 22.3 to 17.3 degrees Celsius. So that means the temperature drops. That means heat had to enter the system to drop the temperature of the surroundings. And because heat entered the system, that means it's going to be a positive Q, positive heat. Was the solution endo or exothermic? So it had to be endothermic because heat was absorbed by the system. All right, gentlemen, so that's it for 6.1. If you have any questions, please let me know. Hit the like and subscribe and all that type of stuff. Bye.